Welcome to the first session operating system and Linux. I'm Manibhushan D'Souza, and in today's session, we are going to introduce you to the operating system. So, these are the topics for today's session. I will give you a brief introduction to the operating system. I will talk about the mainframe system and then about the desktop system. We know that a computer consists of a number of resources. These resources are the hardware resources as well as the software resources. Now, this hardware could be your memory, your CPU, your RAM, or it could be even the hard disk. Now we know that all these devices, apart from this, there are many other devices that are also like your keyboard, mouse, and so on and so forth. So all these devices has to be managed. Otherwise, we will not be able to make an efficient use of these resources which are part of the computer. So we need something that manages the hardware of the computer. Now we know that whenever we use the computer, we use many applications like you may use the Firefox, Chrome or Internet Explorer to browse the internet. At the same time, you may be running the antivirus software. You may also start the Microsoft Word or Excel or any other document. You may be playing the music at the background. These are all the applications program which execute on your system. Now these application programs somehow has to be managed by some utility within the computer so that these applications are used in an efficient manner. Also, we know that the different computers have different types of CPUs, or there may be different amount of RAM and hard disk which are available. So these applications must run seemingly in a proper way in different environment. To do so, there must be something that provides a uniform environment for these applications so that these applications can run smoothly in a different environment. And the operating system is responsible for providing this base for the application program. It's not enough if you have the hardware and the variety of software. Somehow a user has to interact with these resources. Either maybe it is a hardware devices or the resource could be even the programs. Now it is obvious that not everybody who is using the computer knows all the details about the hardware and the software. So there must be a intermediary between the computer hardware and the user, or and the application and the user, so that a user can easily use the computer, and this is provided by the operating system. So what are the things that the operating system provides us? So operating system makes the efficient use of the hardware. It allows the user to execute their program and solve their problem. Okay. Apart from that, it also makes the computer easy and convenient for a user to use it. Now there are two things that the operating system will provide. The operating system will manage the various resources. So operating system will decide how long a application has to run, how long a resource like the memory or the hard disk or a printer or anything for that matter, any hardware resource has to be given to a particular application. So it manages the allocation and the deallocation of the resources. Also, it controls all the activities within the computer. So that means to say that when the input has to be received from the user, when the output has to be provided to the user, how to interact with the input output devices. All these things are controlled by the operating system. So the operating system acts as an allocator of the resources to the various programs, as well as it will control the use of resources within the computer. Now, if you look at a simple schematic diagram of the computer system, at the bottom you will notice that there is a hardware. Now this hardware could be your RAM, your CPU, your disk, and all the peripherals. Now these are electronic gadget. At the top side, if you look at this layer, there will be number of users who want to use these resources. However, they are not very familiar with the internal structure of the hardware. So what they do is they interact with the applications program. For example, as a student, you may write a C program and compile that C program into a machine instructions. For that you need a compiler. In the same way, somebody may even use the assembler to assemble the code, or you may be using the text editor to write your program, or you may be interacting with the database systems. All these are the applications program which the user is interacting with them. Now these application programs somehow has to interact with the hardware. Now who is going to provide that layer? That layer is provided by the operating system. So the user interacts with the application in turn interact with the operating system, and the operating system then interacts with the hardware and make the program work. So there are four different layers are there. We have the hardware at the bottom, then which is hidden by the various user by an operating system, and generally the general user, common user, does not interact so much with the operating system, except that you may change the settings and so on and so forth, but you generally don't interact with the operating system. What the users are doing is users interact with the application program. When I say user, you must understand one thing: user need not be always a human being. User can be other computer which is making a request with the existing computer. So it can be even other machine, something that wants to interact with the computer. So if you look at the bottommost layer of that diagram that was shown over here, at the bottom we have all the hardware devices, like we have the CPU, we have the memory, we have the input output devices. These provide the basic services that are required for the in the computing system. Surrounding this layer, what we have is the operating system. So what is the use of this operating system? Operating system controls all the activities which are going on in the system. Apart from that, it will coordinate the use of the hardware among the various programs which are running on this system, which in turn interacts with the various users. So users start the application, and the application requires some resources, and these resources are efficiently provided by the operating system. You must understand one important thing: there is one part of the operating system. Remember, it is a system. When we say system, that means an operating system will consist of number of components. It is not one program, it is a set of programs that controls the activity. So one part of the operating system is called as a kernel. So kernel is that core of the operating system which will be running always on the system, and it does the basic required task, like scheduling the CPU, scheduling the program, managing the memory, managing the file system, and so on and so forth. So all the core activities of the operating system are handled by the kernel. We don't say individual program, we say kernel. Kernel means something, a set of program that controls the basic necessary programs or necessary functionality of the operating system. The operating system in turn interacts with the application programs. So the application programs, they define the way in which the system resources has to be used to solve a given problem. So the application programs could be like your text editors, usually called as word processor. If you're doing some sort of analysis, you may use the spreadsheet. If you are writing a programmer, if you are a programmer who wants to develop a new program, then you may use the compiler. And if you want to store a lot of data, then you may use the database. And if you are a casual user, you may use the games and so on and so forth. So all of these things are application program. And the last layer that we have seen in our diagram is the users. Now we must understand one important thing: the users are the people who are using the computer. Apart from that, users could be other machines which are asking for the service of the current system, or it could be other computer altogether which want to interact with your computer. Okay. Now, in olden days, today we have the computers, like we have the laptop, even our mobiles are using the operating system like Android, iOS, and so on and so forth. So you can see the operating system, you can see the hardware. Hardware is so cheap that everybody owns a computer or a laptop or definitely a mobile. Now, olden days, these were not the case. In olden days, the computers were very, very costly, and only selected people used to have it. So it is not like you are having your personal laptop or desktop or anything of that type. We didn't had all those things. So what was there is there was a big building with consisting of a very huge computer. Okay, this computer could support a number of users, like hundred to thousands of users were directly connected to this particular big system, and that system is called as a mainframe. You've studied about the history of computer, how the computer came into being, and during that time you have studied about mainframe computers. These are large, very expensive computers which are capable of handling hundreds and even thousands of users. Till today we are using the mainframe computers. Where do we use the mainframe computers? All your ATMs are connected to a very big data centers which use high-end mainframes. So mainframes are used at the very back end where a lot of data needs to be processed. Okay, so there is a huge volume of input as well as huge volume of output has to be produced, definitely in a very optimized way. Okay, and in comparison to our computers, the desktop computers or the mobile computers, these are their speed is measured as million instructions per second, so usually called as MIPS, whereas in our ordinary computer we say gigahertz and so on, or the our peak will be so 3 gigahertz of 2 gigahertz and so on and so forth. That's the speed that we use in our ordinary desktops, whereas we don't say gigahertz there, we are saying how many instructions it's able to execute in a second. So millions instructions, or 300, 400, 1k instructions. So it's able to process 1k instruction in 1 second. Such a extreme speed it's able to perform. Such a this kind of system is called as mainframe system. Okay, so these mainframe systems evolved from the old days computers, which were batched computers and time sharing computers. So the things didn't came, the operating system that you are using today, Android or Windows or anything, it was not a magic. There is a history for everything. So the operating system are also evolved during the olden days, and today you are able to see a very fascinating operating system. So nothing came within one day. It evolved over the time, and the people realized the problems with the system. They upgraded the system, upgraded the OS, and today you are able to see a very efficient, very user friendly operating system. So let's look at the olden days story that was with the batch system. Now, in early days, computers were very huge, and many people could not afford the computer. In fact, nobody could afford a computer. Only university and maybe research lab had a computer. So it was for the organization. So nobody, there is nothing called as a, no, you know very well. You can own a car, you can own a bike, you may own a truck, but not many people who will own a jumbo jet plane. So these jumbo jets, that planes that you see, or train that you see, train is owned by a organization. It's not owned by one person. So nobody says I have my private train. Okay, or nobody says I have a private 747. So, you may say that the president of India has. It is not meant for one person. It is meant for the somebody called as a president. Okay, it's not personal things. In the same way, olden days the machines were very huge, and not everybody like how you are able to play with your tab or desktop or laptop. It was not that kind of a scenario in olden days. These were very huge machines, and like students of computer science who are interested in using computers, if you wanted to use the computer, there was no direct interaction with them. So if you want your program, if you want to test your program, or if you want to do some computation on the computer, then you have to write the code. And in olden days, writing in the code doesn't mean that you are writing in with the pen and pencil, or pen and paper and other things. There was something called as a punched card. You have to punch the various holes for according to your program needs. So it was a very difficult task. What people used to do is, people used to create their job, one job consisting of the inputs required for the program, the control program, how the program has to run, that is your program, and you expect what is the expected output. So entire thing was bundled as a single job. They used to go to the computer center, and they used to hand over uh, uh, their job, and after some time the person will say that okay, you come later, and they will process and give it back. So it is like if you go to the dry cleaners, or maybe the laundry, so you give your shirt and maybe your suit or anything, immediately they won't do anything. They will process it later and they will say okay, come during the evening and collect it. In the same way, olden days it was not like going to laundry, and here you are writing a program with the input and the code, that is a control program, give it to the operator there. The operator will say when the time comes I will give you the output. So when you go during the evening, you may get the result, and or if you are not very careful, if you have done a programming error, you may get the final dump of the output expected results. So you know very well, when you run your program, when you compile your program, you may get a syntax error, or you may get a logical error also. So kind of the same thing, but if in your case you are directly interacting with the computer. In olden days, people didn't know how the computer will look like. You are just writing the code in a punched card, and you are giving the card to them. They will process and give you the result back. So you if you go to the hospital, and if you want to check your test for a blood test, you give your blood, that's all. Then they will come during the evening, we will give you the result. Okay, the same thing as what is done here. You give the program along with the input data, they will give you the output. Okay. So what these people used to do is they used to batch. So if you go to the hospital and you give your blood, there could be many reasons. Suppose if you are testing for malaria, so what they will do is all the malaria related testing, they will keep it as a one batch and they will send it to one pathologist for doing the testing. Maybe other for other infection. I don't know about biology, but at least some other, maybe dengue or other. They will give it to the other. So the same way, these operators, computer operators who are using this computer, they saw the program. Suppose say, let's give you a very simple example. So you want to compile your program. You have written a program in C, written in the sense you have punched it in a punched card, and you want to execute that program along with the sample data. So you say you give the sample code and you give the sample data and you tell them this is a C program. Other person will come and give the program and they say it is a Pascal program. The third person will come and say it is a Fortran program. You have not heard about Pascal and Fortran, but these are the programming language which were there in olden days. But today you may have Java and you might have heard many other programming language. Keep it aside, but these were the programming languages. So what the operators will do, in order to compile your C program, they require a C compiler to be loaded onto the memory. In order to compile Pascal, they have to load the Pascal compiler. Now, if they run a C program, what they have to do is first load the C compiler, then load your program, your data, then unload everything. Again, load Pascal program, the Pascal compiler, Pascal code, and so on and so forth. So what they used to do is they used to batch all the C programs together as a single block. In that case, what will happen is they will load the C compiler only once, load it once, and then just change the code as well as the data. So loading of C compiler again and again, unloading, loading, and it can be avoided. So if you batch all of them, so all the C programs are compiled in one shot. All the Pascal programs are batched together and compiled as a next, and maybe all the Fortran programs are batched together and run as a single batch. So this idea was called as batch programming, wherein the code was batched together, the programs were batched together and then compiled in one shot. However, you must understand here is the input and the output took a lot of time. So during the olden days, till today, your input devices cannot compete with the speed of the CPU. So when the program was compiled, or maybe and the program is getting executed, CPU was input into use. But when there is input output, the speed of input output was terribly slow and the CPU was idle. So there was one problem. Okay, how to increase the speed of the or efficiency of the computer. However, one thing about the olden days program, that is a batch program, was operating system. Remember, in order for you to run the code, there must be some control program which will control all the activities of the operating system. All the activities of the computer, and this particular software is the operating system. So operating system will control and coordinate all the activities which are happening inside the computer. And in the batched operating system, the operating system was called as batched operating system. These are batch operating system, they were fairly simple, very simple. What they have to do is they have to just control the activity of one single job, that's all. So once one job is over, they have to load the second job. So that's the only thing they have to do it. So the idea was very simple. So if you look at the memory structure, memory layout of the old batched operating system used to lie at one corner of the memory, and the remaining area was given to the user program. So operating system will load one user program, execute that. Once that is over, it will remove it from the memory, load the other program, compile it or do anything, compile or process it, and then remove that thing. So this is how the batch system used to work. However, this was not efficient, but there was nothing the olden days people could do it. But later, the hardware technology changed and the disk technology started. Now, disk, you know very well, disk is a random access memory. So what is the meaning of saying random? It may not be perfectly random access, but you know very well it is you can randomly pinpoint anything. So disk was much faster than tape or the punched card. So what happened is many programs were kept in the disk, and the speed of a disk was far better than the speed of the punched card. So what the people used to do is they used to take the punch card, read the content of the punch card and put it in the disk. So the operating system, what it used to do is there are many programs in the disk. It will pick one of the program, start executing it. Okay. So, because the disks are direct access, we don't say the random access, they are direct access. You can directly take any code, any segment of the from the disk and transfer it directly onto the memory. So, this was the beginning of multi-programming. So, in multi-programming, what happened is more than one program was kept on the memory. Okay. Now, in order for the operating system to do that thing, it must first decide which program will be loaded into the memory. So there are many programs which are there in the disk. One of them has to be taken and then put it onto the memory. So there was the operating system became slightly complicated because scheduling was required. What is the meaning of scheduling? Scheduling is controlling what? Controlling which program will be loaded next. So there must be some decision that the operating system has to do it, and this is called as scheduling. So there was your operating system which was very simple in the olden days, where it was just controlling one program. Now it has to control more than one program, and it has to decide which will be loaded into the memory. Okay, so one of the most important aspect of the multi-programming idea was job scheduling. So in order for the operating system to load more, in order for the computer to have more than one program in the memory, those program has to be loaded into the memory. Which program has to be loaded? For that, some decision has to be taken. There must be some control. And who is going to control that thing? That is controlled by the job scheduler. So the work of the job scheduler is to decide which program will come into the memory. Very important thing about the multi-programming idea is in multi-programming, the system will contain more than one program active in the memory. Memory in the sense in the RAM. However, these programs are taken from the disk. Okay, there will be many programs in the disk. Some of them will be picked up and put it into the memory. So we say there is a job pool of job in the disk. So the disk contain many pool of job. Some of them will be taken and given to the or and fed into the memory. Okay, so what is the advantage over here is, remember, a single user, whatever efficient he or she may be, they cannot keep the system CPU or input output system busy. In other words, they cannot make the efficient use of the computer system. So you may have to have more than one program active in the memory so that the CPU can be utilized to the fullest extent. Okay, so what is done over here is, as I've already told you, there will be a job pool. Now what is this job pool? There will be many programs in the disk. So there will be many programs in the disk. Some of them will be taken and put it into the main memory. So whatever that is there in the main memory, that is the RAM, can be executed. So what is there on the disk cannot be directly executed. So what is there in the disk is the job pool. Okay, subset of it is taken up. Okay, subset, not more than one, you can take it and then placed into the memory. Okay, so what the operating system is doing, it keeps more than one job or more than one program in the memory so that they can execute one after the other simultaneously. Okay, so what is the advantage about this? Advantage is when the CPU is free, doing nothing, other job can be given. So the structure of the operating system slightly changes. So we have the operating system occupying one corner of the memory. There will be many jobs which are simultaneously loaded in the memory. So any one of them can be given to the CPU. So if one job is it got stuck, the second one can proceed. If the second one got stuck, the third one can proceed. In other words, if the CPUs or input output devices are not idle, because when the process is making some input output request, CPU is generally idle. Instead of keeping the CPU idle, the second program can be executed so that CPU can be made busy. Okay, so how does the multi-programming system works? So the operating system picks up one of them. So remember, there will be many process or many jobs in the memory. So assume that this is your RAM and you have your CPU. The operating system picks up one of them and gives it to the CPU, okay, and start executing. When I say it gives it to CPU, means what is the work of the CPU? CPU will execute the code. So the CPU will execute the code. However, after some time, it may so happen that this particular program may get stuck because it may want some input, okay, or it may wait for some task to happen. So in that case, what happens, when there is an input output activity, the CPU will be idle. So if the CPU is idle, definitely the efficiency decreases. So what to do in that case? In this case, what is done is the operating system switches this program and picks up some other program and starts executing. So what happens is when one program starts, if it is making input output request, it is stopped there only. Some other program is executed. If that some other program also makes an input output request, third program is taken. So this way operating system switches from one job to the next job. So when the first job is waiting for input output, the second job is started. If the second job is waiting, the third job is waiting. The third job is started. If the third job is waiting, fourth job is started. And eventually, remember, it doesn't mean that the first job which was waiting will wait forever. So first job may eventually complete its input output work. In that case, the first job will be started. So in other words, there is kind of a scheduling that is being done between the various job. Okay. As long as at least one program is running, the CPU in this case will not be idle. Okay. So there now the operating system becomes slightly more complicated. First is it has to choose. Remember, there are look at the complication that the operating system is having now. So there are many jobs in the job pools. Okay, operating system has to pick some of them and put them into the RAM. So this is one scheduling. From this, there are many programs in the RAM. One of them has to be given to the CPU. Okay, so again scheduling. So operating system has to make a lot of decisions. So in the if you compare it with the batched operating system, it was not making much of a decision, whereas this multi-programmed system, the operating system is making a lot of decision as to when a job has to be started, when the job has to be stopped, and so on and so forth. Okay, now the question is, you have the memory here, you have the disk, let's say you have the disk here. Now which program has to be loaded into the memory? So in other words, in order to load this code program into the memory, some memory allocation has to be done. If the program completes, some deallocation has to be done. So again, you need to make you, when I say you, the operating system need to make some decision as to where to allocate, where to deallocate. In other words, this is called as a memory management. So the operating system became more complicated because it has to manage even the memory. Okay. Next one is the job needs to be which are there in the queue has to be executed. So you know that let's look at here. You have this lot of jobs which are there in the memory. One of them has to be chosen and given to them. Which one? Okay. So again, some decision has to be made as to how to schedule the CPU. Scheduling the CPU means, remember, scheduling the disk means to access the content into the memory. Scheduling the CPU means which program will go to the CPU, which program will halt, which program will get terminated. That has to be again controlled by the operating system. And you notice that operating system has become more complicated. Okay. So this led to some other thing. Now what happened is this, if you look at this one, it was only one program which was running. So in the batch program, in the batch environment, there was one program which was running, whereas in the multi-programmed environment, more than one program is running. So in the batch, only one program, one job at a time was executing. In multi-program, more than one program is executing. But if you look at this environment, in both the environment, the user is not interacting with the operating system. They just give the job. The jobs is there in the job pool. Operating system will pick up some job and execute it. But there was no interaction. So what to do in this case? In this case, the people thought, let's make the operating system more user friendly by allowing the user to interact with them. So here what was done is the multi-programming environment. What is multi-programming environment? More than one program is there in the memory. Now that's not the end of it. They thought, why not having a interaction among the user, so that the code will become, or the computer will become a live entity as such. So what was done in multi-programming environment is, remember, the olden idea was you have the jobs here, you pick up some job, put it into the RAM, and you take some of them and give it to the CPU. Now that's not the end. So in that case, what will happen is this program is loaded. It will take half an hour to complete. The next one, if there is no input output, the next one will take 1 hour. Next one may take 3 hours for completion. But more than one program is there. CPU is utilized. Everything is proper. But there was no interaction. So what is to be done? The idea here was, they thought we will not just give. So in olden days it was if this program is running for half an hour, it's okay. If this program is running for 1 hour, it's okay. But now they said that we will divide the time of the CPU among all the users. So if 10, no, you know, when we are playing cricket, not the tournaments and other things, if you are playing cricket near your house, so what we will do, sometime how we play is everybody will get 1 over, that's all, 1 over, or 10 balls, that's all. So that's it, we have 2 hours. So if 5-6 friends are there, everybody will get 1 over. So 1 over batting, 1 over bowling, that's it. So everybody will get it. There is no team, nothing, because we don't have 25 people over here or 20 people over here who will create a team, and such a thing is not possible. We have 5-6 people, so what we'll do, we will share our time. So 2 hours are there, we will start at 4 o'clock, 6 o'clock we have to reach home. So what we will do is, for everybody we will say, okay, 1 over for one person, or 2 hours per person. If he is run out in between that or is out between, then it is their problem. Okay, they are out. But everybody will get a chance of 2 hours maximum, 2 hours maximum. So that's the, or 1 hour maximum. So this is the idea that we do. In what we are doing there, we are sharing our time. That's all. The time is shared among all our friends. In the same way, here the CPU time was shared among the users. So multiple users are there. So here in the previous time, CPU time was not shared. You load one program, if it is asking for input output, load the stop it and load the other program. In this case, it is not. Everybody is given some small time. So let's say 1 millisecond. Everybody is, or 1 second. Every program is given 1 second. It says, okay, for 1 second you can execute it. After 1 second you stop. So it is like after 1 hour, whether you are out or not, you will have to leave the bat. The same idea how you were doing it. So same thing. If you are out before 1 hour, first of all only you are bowled, you have to leave the bat and go. So that is the idea that was there. So if the program wants more than 1 second, it has to wait for the next round. So if we go in cycle, first program is given, 1 second is given to them, you complete it. If you don't complete it, wait, come next second program, 1 second, and so on. So it was the what was happening is CPU will switch among the different process. Now the other problem that came into the picture was interaction. Now this CPU can switch between one program and the other. That's well and good. But what about the user interaction? There was no user interaction. Remember, in old days, the interaction with the computer was not so easy because the keyboards were not there, mouse was not there, your touch was not there. But now the new technologies have come. So we need to interact with the computer. I want to type something, send a command, want it to be executed. I want to click and want the interaction. So what is being done now is, so if the computer is able to respond to you within a millisecond, then you will not make much of a difference. So remember, millisecond is maybe it is a very tiny time for you, but for a computer which is you working at a million instruction per second, it is nothing. So it is able to perform trillions of operations within a second. So what the computer will do is, for 1 millisecond your work is done, immediately it will switch to the other person. So I type a command, whatever I type, the command will be very short. The computer immediately processes it. Then when I type the next command, it will simply switch to the other person who is connected to the computer. It will perform their work and then to the next and so on and so forth. So it was the computer was able to respond back in a very short time, maybe 1 second or 1 millisecond. And what we find as a humans, what we find, computer is able to interact with them. We are able to interact. We type some command, we get the result. We type the next command, we get the result. But what the computer internally, what the operating system is doing, operating system is switching from one to the other. So let's assume that you are typing a command, you have sent it. After 1 second, your code, other person's code, it will execute. After 1 second, other person's code, it will execute. So this is very rapidly, it will switch from one user to the other user. So we find that the computer is able to interact with them. Okay, so many users can share the computer. Okay, each user types a short command which takes a smaller time for the CPU to execute, and immediately the computer rapidly switches to the other person. So what we find that the computer is dedicated only to me, but in turn computer just switches from one to user to the other, and this is carried out by the operating system. Okay. This operating system which is using this kind of scheduling is called as time sharing OS, and this time sharing OS is still more complicated because there will be more than one program active in the memory, more than one user active in the memory, and it has to control all of them. So it becomes it became still more complicated. So from the simple batch OS operating system which had only one program, now we had more than one program and more than one user. So it became still more complicated. Okay, so the operating system became more complicated because several jobs are kept. When the jobs are kept, there is a need for memory management as well as protection is required, because see, I can write a malicious program, my code is there and your code is there. I can write a manipulate something and destroy what you have done, so there must be protection. What I am doing as a user, I don't want somebody else to distract or interact with my code. Okay, so also the operating system must be able to respond back to the user within a reasonable time. Otherwise, the people will think that computer is not responding. So what the operating system must do is, if there is a long complicated work to be done, it has to be swapped out of the memory so that this short program can be executed. So all these things required the computer, the operating system to become more complicated, and in turn, when you are loading very lengthy program, the program may not directly fit into the memory. So what to do? The operating system creates a visualization or a virtual memory and then starts loading it. Apart from that, the operating system has to interact with the disk, and in order to interact with the disk, there is a file system that is required, which will manage the data which is stored in the disk. And it is not just one disk, operating system can interact with more than one disk. So a kind of disk management is required, from which disk it has to read, what it has to read, where to write it, how long it has to write, all these required again one management. So we have CPU scheduling, memory management, disk management, input output management. So the operating system here become more complicated. That's not the end of it. So the users who were using the computer, they wanted the program to execute parallelly, concurrently, one with the other. How to achieve this? So in order for the two programs to simultaneously execute, some additional CPU scheduling was required. So very complicated CPU scheduling came into picture. Also, sometimes there is a need for coordination. First this will happen, then the next thing will happen, then the next thing happen. For example, first you read the input, then you process it, then you put the output. So if you start the putting the output first, then you will not get anything, any good result. So there is a orderly way in which the program has to be executed. Also, sometimes there is a synchronization that is required between the two programs. Suppose if I am transferring money from my account to the other account, some sort of synchronization is required, because first I have to delete the amount, put the money into the other account, and when both the accounts are properly tallied, I have to disconnect. Okay. Sometime it may so happen that the computer, one program may wait for the other program may wait for the other program, and so on and so forth. That can lead to a deadlock. Deadlock is like your traffic jam. In traffic jam, what happens is you are expecting some in front of you, whoever is there, to move front, but that person is expecting whoever in front of him to or her to move front. So what happens is finally you notice that everybody is in a circle. So everybody is expecting the others to go. So for example, you expect the other person to go, other person expects somebody else to go, and that somebody else expect someone else to go, and this someone else expect you to move. So nobody is moving. So this is called as a deadlock. This is what happens. So one process requires some resources that is there with the others. Other requires some resources which is there with the third one. So it is waiting for the other. This is waiting for the next program to complete so that it can get those resources. But the last program is waiting for the first one to complete, because some resources are there with the first one. So this will lead to a deadlock wherein nothing is going to happen. So all these complications were there taken care by the time sharing system. Now, but the good thing about it is in the later development in the 80s, the computers became very miniaturized and people started using personal computers. So XT, IBM XT or IBM PCs at the beginning, which were using Intel microprocessor, and the history. You studied the history about the computers. So in the personal computer, what happened was the machine was not very complicated, very powerful, and other things. Machine was a very ordinary machines because a user cannot compete with the mainframe. It was a dedicated machine to the user with containing keyboard, mouse, and display screen, printers, and so on and so forth for a simple user. And what was the main requirement over here was it must be convenient for the user to use it. So if you ask the user to type the command, they will forget the command. So some sort of interaction was there. So if you just imagine, you are calling your friends. Suppose instead of calling, when you're calling, you are just pressing some numbers and then press a dial. Then the phone is going to get connected to the other person, but there is internally a lot of complications are involved. What if somebody says for calling the command is call to, and then you have to type your number, then you have to type Airtel or BSNL and so on, so you have to type a very lengthy command, then only you can call. Then people say that that is not convenient for us to use. We can't remember all the commands. So to read the SMS, read SMS and the number of the SMS, and so you have to type all these commands, means people say it is very difficult for them to use it. So when we say personal computer, they must be some sort of machines which are convenient for the people to use it. So these machines are often used by one person, okay, single use, okay, and they don't require very complicated CPU utilization, CPU scheduling, and this kind of thing, because generally one user, you know very well, they cannot compete with the speed of the computer. Even if one user is there, even if you load 100 of programs, it is you can't keep the CPU busy. Okay, so it's not that case. However, the other people, like other, when I say other people, non-computer people who are not really interested in knowing the details of the computer. So you know very well, when you get a fever, you go to the hospital, and what you want is a medicine that will reduce your temperature, and so that you can move out. But your doctor may say you have viral infection, you may have malaria. Who cares? Okay, that's a question. But for them, it is a very big thing. So they will say that parasite has come, this glucose has to be given. For them, all complication. In the same way, for the others, you may be very much interested in the computers to know that this is a CPU, this is a hardware, this is a RAM, and so on. You want to know everything about the computer. For others, it is not that thing. I want the result, that's all. I want to do some computation, I want to draw some graph, I want to play music, I want to surf the net. That's the end of it. How it is doing, that's all. They don't care. There were many operating systems which were developed for the desktop operating system. Some of them were your famous Windows. In Mac OS, we have Mac, many OS are there, and Unix and Linux and so on. So these were the operating system that were used in the desktop system. That's all for today. We will meet again in the next class. If you are really interested in knowing more about this subject, please refer the Galvin's book on the operating system. Thank you.